All right, hello and welcome to C++ 102, Week 5. Today, I'm going to be here. My name is Nelson. So what we're going to be doing today is we're going to be taking a look at operator overloading. And operator overloading is a fun little topic that has a few caveats that we need to discuss, similar to the discussion about operator overloading in C# that we had, I believe, last week. It's an interesting concept. It's abused quite a bit, but it's an interesting thing that is applicable to, well, it's applicable where it's applicable to, and we'll talk about that in a moment. The interesting thing about operator overloading in C++, there's actually a few interesting things. One of them being that you can actually define operator overloads outside of the actual class that you're working on, which we'll see in a moment, can actually allow for some interesting debug possibilities. Another interesting thing about operator overloading in C++ is the kinds of operators you can overload. And the fact is, you can overload quite a few operators in C++. You got all the arithmetic operators, you got all the assignment operators, and we did talk about the assignment operator last week. But you also have things like the parenthesis operator or the comma operator. So I want to point out, again, I really like talking, whenever I talk about a feature of C++, I really like talking about all the different, strange kind of esoteric things you can do with the syntax, not necessarily for use in code or any of the code we're going to be writing or any of the code I would suggest you would write, but to facilitate reading other people's code. I think that's a very important thing, even if you don't, overloading the comma operator, I mean, who's going to do that? But if you see somebody, if you're working with the legacy code base or code base developed by somebody who thought it was a good idea to overload the comma operator, I don't want people to be surprised about it. Because one of the things about C++ is that it supports so many bizarre syntaxes. And I don't know if that's actually the correct structure of the sentence I just made. I don't believe syntaxes is the correct plural form of that word, but you get what I mean. Because of the amount of bizarre, strange things you can do with the C++ syntax, oftentimes reading C++ can be very intimidating if you are not aware of them. So, yeah, let's go ahead and fire up another project, and let's talk about operator overloading. I swear, one of these days I am going to get a conflict. In fact, I don't even know what'll happen if I get a conflict. I don't know if it's going to overwrite or warn me or do some crazy merge, but one of these days. Alright, so I'm just going to fire up a project, create a new source file. Bring in some stuff. I'm going to bring in Ostream, and I'm just going to bring in string as well. Then I'm going to go ahead and import the std namespace, and then I'm going to open up main and return 0. So we have a basic structure of our program ready for us. So what exactly is operator overloading? Well, in C++, what you can do is you can define your classes to overload operators. And what I mean by overloading operators is the different sort of binary and unary and N-ary. We'll talk about the N-ary operator in a moment here, or during this class, but primarily you're going to be overloading the binary and unary operators in C++. So when I say a binary operator, what I mean is, for example, this is a binary operator. This is multiplication. And it's a binary operator because it has two operands. In this case, it's being expressed by 2 and 2. Those are the two operands to this operator. Now in C++, operators are not treated like methods when applied to primitives, meaning that in this case 2 and 2 are both integers, and them being primitives, they don't get treated as function invocations as much as actual instructions that the C++ compiler emits in assembly. But it is an interesting thing to think about, where you have what's called right here a infix syntax, where the operator is between both operands. However, it's nice to think about, and especially in the context of overload. I just combined operator and overloading the same word. Wow. operator overloading, it's useful to think about things in a sort of prefix notation. So although this is not valid C++, you can think about this as a function that takes in two parameters. In this case, the multiplication operator. Now I do want to point out that when we do our own custom operator overloading, we can represent stuff in the syntax, but obviously in C++ the way it is right now, we can't because we're working with primitives. It is interesting to note, just as an aside, because I love languages, for example, in F#, you can use prefix notation for all operators, because in F# actually treats all operators, including those between primitives, as method invocations, or as more appropriately, it treats them as functions. And there's quite a few functional languages you can do this with, but in C++ you can't. I'm only pointing this out for illustrative purposes. So we have operators, and we have quite a few operators. We have multiplication, we have addition, we have division, we have subtraction, and we also have corresponding operators for assignment. So for example, I can do I plus equals 2. And I know everybody knows this right now, but I'm really wanting to point out and have people start thinking about the fact that what we're doing right here now is we're applying a function, in this case the addition assignment operator, to two operands, in this case being I and 2. Again, if I were to write this out in C++, invalid C++ syntax, I could say plus equals I2. And that would be what a function invocation would look like if we had the ability to use prefix notation with our operators. So, yeah, so we have different operators that we can overload. So we have subtraction. We have assignment, but I'm not going to be talking about assignment this week because we talked about assignment last week. We have multiplication, division, addition. We have the corresponding, minus equals, multiplication equals, division equals, plus equals. We have the prefix and postfix increment operators. And what's funny is there is an actual way to overload both the prefix and postfix operators, which is interesting. I want to keep in mind, I hope everybody knows the difference between the prefix and postfix increment operators. Just a quick recap. Let's say we have I and we set it to 1. I mean, what's the output to this program? An error. What's the output to this program? Anybody? We have a 1 and a 3, we have a 2 and a 2, we have quite a few 2 and 2s. The actual output to this program, just for proof, is going to be 2 and 2. The reason it's going to be 2 and 2 is, again, it looks like a few people actually haven't been exposed yet to the prefix and postfix increment operators. I want to point out that they behave just like the prefix and postfix decrement operators as well, decrement being minus minus. So plus I is the prefix increment operator. What that means is that when this operator, or when this expression or sub-expression is evaluated, keep in mind that what we have going on right now is something like this. I don't know if this is going to actually let me do this. Probably not, because it's ambiguous. It's wanting to do an unsigned char. Let's try to cast this into an int, see if it'll let me actually get away with the syntax. Now, it's not going to let me do the syntax, but essentially this is what we have going on. The left binary shift operator is a binary operator, obviously, because it's the left binary shift operator. Actually, funny thing about that's an ambiguous binary term. It's the left binary shift operator because it works on shifting bits within a byte. But it also is a binary operator in that it takes two operands. And so what we have here is a method invocation to this operator, passing in cout and I plus I. And what happens here is, keep in mind that arguments to function invocations always get evaluated before the actual function invocation. Meaning what we get here is this sub-expression actually gets evaluated first. And whenever you see a plus plus I or plus plus whatever, prefix increment operator, whenever you see that, that means that the increment to the variable is going to happen first, and the value of incrementing that variable is going to be returned and used as the value of the expression. That means that the result of line 9 is going to be 2, because I is already 1. And then we increment I and return 2. The postfix operator works a little bit differently. The postfix increment and postfix decrement operators simply return the value of the variable as it was, then performs the increment or decrement operation after the entirety of the expression has been evaluated. So that's why we get 2 here. Now, if I were to do one more thing, what's the output of line 11? Right, 223. I inadvertently printed out the caliber of my assault rifle. So, yes, it's going to be 3 at the end. And that's because although the value was returned before it was incremented, it did actually get incremented. So that's a quick rundown of the prefix and postfix operators. And one of the funny things is what we're going to be talking about is some really fun stuff in terms of how to actually overload both the prefix and postfix operators. Is a funny bit of syntax that I laugh at every time I see in regards to that. So let's talk about operator overloading. I'm going to go ahead and create a class that's a prime candidate, and people from C# may remember this particular example, but this class is a prime candidate for operator overloading. So I'm going to give it a constructor. We're going to pass in a float x and a float y, and then we're going to use our initialization list on x and y. And then we're going to add a few, float get x, const return x, and then a float get y, const return y. So I have a fairly simple vector2 class. Now, if I had a vector2, my vector2, 1, 2, and then I had another vector2, my vector2, I'm just going to call this my object1, my object2, and then just like that. And then if I went ahead and did something like cout my object1 plus my object2 dot get x. Now I want to be able to support this syntax, and the reason is because when working with stuff like vectors or matrices or primitive data types, or maybe you have a class that's a wrapper around primitive data types. For example, maybe you have a Big Int class, and a Big Int class is a very common pattern in programming where you create a class that can represent an integer of any arbitrary value. Now keep in mind that, for example, a 32-bit integer can only store the values between negative 2 billion and 2 billion, but a Big Int class will be able to store integers at any particular size, simply because they'll use dynamic memory allocation to sort of abstract that away. So there's a lot of times where overloading operators make sense, and this is one of the cases where overloading an operator does make sense, because what we're doing here is we're working with mathematical constructs. It's important to realize, though, before I actually show everybody the syntax for operator overloading, yes, we did see a little bit of it last week, and you probably could infer it if you remember the overloading the assignment operator. But there's one very important caveat to this, and that is operator overloading may be abused, and it is quite often. See, a lot of programmers think that, let's say I have a customer, and then maybe I have an invoice, and maybe I want to make an order. So some clever programmer says, okay, well, I can support the syntax by saying customer plus invoice. That doesn't make any logical sense. Well, I guess it kind of does from the perspective of us reading that, or the scary way that particular programmer conceptualizes the world, because it's obviously non-standard. But it really doesn't work, and there's a reason why this doesn't work. I don't want to leave this out as saying, don't do this. I'm actually going to give you guys a very important rule as to why you shouldn't do this, and that is operator overloading should only be taken advantage of if there is one and only one way to interpret what overloading the operator does. Which means that for a vector 2, you should not overload the multiplication operator. That's because there's two ways to multiply vectors. Because if you're reading through the code, you can get lost very easily not knowing exactly which algorithm is being used to perform the multiplication. What really should happen here, because, again, this is bad, and this is bad because there is not one and only one way to add a customer to an invoice. Because saying that doesn't really even make sense. What you should instead do are use other tools that you're given in the C++ language to express this logic. One way could be through a constructor. You could say order customer invoice. That's a nice little way to do it. Or you might want to say something like, maybe you have an order factory. Create customer invoice. That's another way to do it. Alternatively, maybe the invoice method has a create order method, or the invoice object has a create order method in it that takes in a customer. All of these alternatives are much more preferable than using any sort of operator overloading. So do not use operator overloading pretending that you're clever. You should only use operator overloading if there can be no misinterpretation or ambiguity as far as what you are trying to express with your code. So, getting back to this, how can we make this code work? I do really want to step back for one quick second, and people might not actually be very comfortable with this syntax here. Notice how I'm wrapping a particular expression in parentheses and then using the member resolution operator to get something out of this expression. What's actually going on right here is interesting, and you'll see me using this syntax quite often in both C++ and C#. But what is actually happening, for those of you who may be confused, is we're basically creating an intermediate vector. So let's call this result, and then we're assigning result to the result of the application of the addition operator. And then we're invoking getX on result. So I'll just leave the code like that, but if you see me wrap different bits of operator invocations or method invocations inside parentheses and invoking members on it, keep in mind that it behaves just as if we had used an intermediate local variable. So as far as actually doing the addition operator, let's talk about how we can do it. Well, the first bit is that I'm going to go ahead and write out a similar bit of syntax to what we saw before. So we're going to start with the return type. Now, the return type of this operator is going to be simply its type as a reference, which means it's simply going to look like vector2 reference. Then I'm going to go ahead and write down, actually, wait a sec. Actually, I'm going to finish writing this code out, and then I'm going to ask people why it's a horrible idea. This should be fun. So then we're going to do operator addition, and then we're going to take in a const vector to right-hand side. And then I'm going to say, vector to local x equals x plus RHS x, local y equals y plus RHS y, return local. Now, can anybody tell me, actually, derp, can anybody tell me why this code is problematic? Look very closely at line 18. I made a small mistake when writing this code out because I was actually thinking about overloading a different operator than the addition operator. And this code is actually going to be bad. All right, atomizer K7, Zolkaz. Yeah, basically this is bad. If I run this code, it's probably going to work. As you see, it actually works, sadly. Let's see if I can manipulate this in a way that is interesting. Blah, 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 blah. Okay, I can't quite get the stack frames to align, but basically the reason why this code is bad is I'm returning a reference to a local variable. What I really wanted to do was return a copy of this. Now this isn't true for all operators. Not all operators should return a copy, but certain operators have a particular convention in that they're expected to behave in a certain way. See, the addition operator should always return a copy of something because we are creating a new thing. As you see right here on line 31, we are creating a new thing. We are not mutating object 1 and object 2. Now, that isn't to say that I can't mutate anything within this addition operator. I certainly could. I could mutate my x and y local or my x and y fields, but that would be sort of breaking the kind of implicit contract of what addition means. Addition does not mean to alter anything. Addition is about returning a new thing. And I can't return a reference to a vector 2 because at this point I'll be forced to be returning a local variable. It actually did give an alert here as well. Notice how it says returning address of local variable or temporary. And do not ask me why in Visual C++ this is a warning and not an error. Further reasoning why you should always treat warnings as errors, especially in C++. Like especially in C++. Certainly, I could return a reference to the right-hand side, but it's not going to do anything. Somebody said they just returned an invocation of the constructor of vector 2. So as this is my code right here, I'll just leave it down here and I'll comment it out. What they wrote was something like that, which will build and will work. Of course, let me fix this really quickly. So this will build and this will work the way that we expected it to. And it most likely is more performant. Most likely is. Now, when talking about performance and micro-optimization like this, it's really important to consider the fact that people a whole lot smarter than both you or I or anybody who's ever going to be watching any of these videos have spent time building up a great optimization compilers that sort of can detect these sort of things. Now, there are ways for this and this to perform different behaviors. So it might not be possible to be in an optimization compiler, but the fact is this will be more performant unless the optimization compiler turns this into this. The reason being is that we invoke the constructor and then copy out something, as opposed to invoking the constructor, and we also do a copy as well. So if you overload the increment operator on a vector, would you then return a reference or just take in a reference? Yeah, we'll talk about the increment operators in a moment here. So again, there's one more interesting thing about this method, is that notice how I can quite easily add the const modifier to it. This is an appropriate place to put constness. I want to point out that the addition and subtraction and any of the operators that have the implicit contract of returning a copy, again, it's not necessary that I return a copy. I could return a reference to itself if I wanted to. I could do anything. I could, I could allocate memory. I could talk to a database. I can jump over the network. I can delete my C drive. I can send an email in this operator, but there's an implicit contract as to what this operator should do, and this operator shouldn't mutate anything, and it should be const. But there's one more sort of rule that I'm kind of breaking here. I'm not expecting many people, or really anyone, to get this rule, especially considering the fact that I haven't even told you guys what the rule could possibly be. But there's one more interesting sort of rule about operator overloading that you should keep in mind, and it goes back to the sort of implicit contract that each one of these operators provide, because each one of these operators, addition, subtraction, multiplication, division, modulus, shift left, shift right, and so on, have a sort of implied meaning. But there's a rule that I'm breaking right here. And actually, I'll call it a rule because rules can be broken. It's not 100% of the time that you will follow this rule, but it's good to be cognizant of, especially in design, as to not confuse people who consume your code. Any ideas? Again, I doubt anybody's going to get this. Cesar is pretty much correct. It wasn't actually the, yeah, I mean, that's pretty much exactly what I was going for. The rule for these sort of operators are that you should really overload the similar operators. And there's a lot of operators with interesting relationships between the two. So, for example, in this particular case, you could argue that subtraction is related, I guess. You could say that subtraction, in fact, I would almost say that in this particular case I would include subtraction. But in this case, the thing that you cannot break is that you really need the plus equals operator. Now, the plus equals operator, can anybody give me the signature of what I should change this to? Anybody? Bueller? Can anybody type out the entire signature of what this should be? Because there are two problems with the signature. In fact, the two problems with the signature are actually contradictory of what the actual meaning of this is. K7, I'll get to that in a second. Yeah, I'll get to that in a second. That's not exactly what I was going for. Dak, you are close, but you're missing some things. Again, there is no hard and fast rule. Well, there are rules, but there's no hard and fast language requirement that a signature of any operator needs to be in any particular way. In fact, I could quite happily compile the code as it is, but this is nonsensical. The reason it's nonsensical is we are breaking an implicit contract. The one thing about this operator is that I'm contradicting myself. The plus equals operator, by nature, is supposed to assign the results of an addition operation to the thing it was applied to on the left-hand side. Meaning, you should really remove this const, because that is contradictory. So remove the const. The next thing is this particular case, we really should return a vector to reference. Now, it's not a hard and fast rule, but if we don't return a reference, then we can run into some interesting problems, nonsensical code, confuse our client, the consumers of our code, and all around waste memory and CPU cycles. So the way that I would go ahead and implement this method is fairly straightforward. X plus equals RHS X, RHS Y, return this. Okay, so there's a few interesting things about this. Again, going back to the rule that you should never break, you should always overload things that are related. So if you overload addition, you should overload the assignment addition operator. Next thing, we mutate our variables. We return asterisk this, which looks a bit funny. I don't know if we've talked about this before, but keep in mind that this is a pointer. To convert a pointer to a reference, we use the asterisk operator, unary operator. Now, I also, again, I just want to stress this fact. There's no reason why you can't have a signature of an operator overload be whatever you want it to be from a code or compiler standpoint, but there is a reason from a semantic standpoint and from the standpoint of consumers of your code being confused when using your code. Again, another interesting thing, C# will automatically overload this operator if it finds that you have the addition operator. The final thing, I mean, I don't really want to go on break just yet, but I have I'll just ask this question out on the recording. Can anybody give me an implementation of this operator that reuses the implementation of my plus equals operator? Now, this is particularly interesting how, and I'll talk about it quite a lot, where you can actually reuse operators. And you should reuse operators, because right now we have duplicate duplicate stuff and things. And wow. Nelson, got it backwards? What did I get backwards? No, I didn't get it backwards. You can override, you can write this in terms of this. So DAC says return this plus equals RHS. Now, what we're going to get here, though, is a issue with, well, an error. Now, keep in mind that this is actually going to modify our this, and we don't really want that. A cleaner implementation, or an implementation that doesn't have those problems, could look like this. So what we're doing now is why does line 20 compile? Anybody tell me why line 20 compiles? Can anyone tell me what line 20 does and why it compiles? All right, K7 got it. Roland got it. Well, now that I've told everyone that they got it, now it's kind of pointless to carry on. But what we have here is an invocation of the default copy constructor. Keep in mind that every custom type comes with a default copy constructor that will simply invoke the copy constructor of all of the local fields. So we take advantage of that fact. Then we do this with our RHS and we return our local. And that's it. I would consider this code significantly cleaner than what we had before, because now we're not duplicating our behavior. Our behavior is now in one place. Even though we have two similar operators, we now only have to maintain one implementation of our addition. So it's a handy little trick and something to keep in mind when doing all sorts of fun stuff. Okay, so now that we have our operators working, so you see that we get 2 because result is 2. So I'm going to bring this back to a cleaner way of writing this code. So we have my object plus 1 plus my object 2 dot get x, and we get 2 because 1 plus 1 is 2. So that's really fun. Does operator plus not have to go after operator plus equals just because it's in the class instead of being a function? Yes. That's a good point to make. Classes are you don't have to forward declare members in classes. So for example, I could have quite easily defined my fields at the bottom of this class, and everything just works. So the order that members appear in is not going to be the same, or not going to have the same restrictions as the order of non-members. So keep that in mind. When we're working with free-floating functions and free-floating variables and all that fun, awesome, horrible stuff, order does really matter, and you have to worry about a lot of forward declarations and all that stuff. But when inside of a class, you can reference any member from anywhere. That being said, I really like my fields to be at the top of a class, personally. And if you say that's stupid because you have so many fields that it drowns out the rest of your code, then I'll respond with, you have a big class that shouldn't be as big. Okay, so here's our addition and our addition assignment. Let's talk about the increment and decrement. So the increment and decrement operators, I'm going to end. This is slightly nonsensical on a vector 2, but I just do not have the time right now to create another example of another thing that has an increment operator. So forgive me for this being a stupid example, but hopefully you guys will see where I'm going with this. Although I think we did have a question. Oh yeah, so if you overload the increment operator on a vector, would you then return a reference, or just take in a reference? Well, I'll do both. Oh, no, I wouldn't do both. I would just return a reference. Keep in mind that both the prefix and postfix increment and decrement operators, they are unary operators. Now, I haven't talked about free-floating operators yet. We'll get into that in a moment here, probably after break. But keep in mind that for all of the operators that we have at the moment, there is an implicit LHS. Think of there being an implicit LHS parameter that comes in here. Unlike in C#, where all operators overloads are static, where you have to take in both the left-hand side and the right-hand side, if you declare an operator inside of a class in C++, the left-hand side is implied. So let's go ahead and overload operator ++, and we're going to return a reference. We really should return a reference. So what's this operator going to do? Again, it's a silly operator to begin with, but whatever. And of course, I misspelled that. Okay, so now we have our operator ++. If I want to go ahead and prove that it works, which it does, I can say vec ++, and I can say vec.getX, new line, vec get y, run this, and we'll get a nice little 3 and 2. Now I did notice something pop up. Oh, no postfix. Yeah. What I did right here was that actually isn't what I wanted to do. I wanted to do the prefix because I actually overloaded the prefix operator, not the postfix operator. But Visual C++ said, or just assumed that because I didn't have a postfix operator, but I had a prefix operator, I was just going to use the prefix inside the postfix and all that fun stuff. So, you guys ready for some awesome syntax? Syntax that just makes me nice and warm and fuzzy on the inside? So, in C++, you can overload the postfix increment operator and the prefix increment operator, as well as the postfix decrement operator and the prefix decrement operator. Can anybody guess as to the signature of the postfix increment operator? I'll give you an internet cookie if you can guess this. Nope. 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 So a lot of people are going for the obvious route, stuff like this. You know, maybe it appears behind the operator. No, that doesn't work. Maybe it appears after the parentheses. No, that doesn't work. Maybe there's a special keyword called postfix. No, that doesn't work. What works is taking in an integer. I'm not even kidding. So if I go ahead and write the postfix form, keep in mind that this integer parameter doesn't do anything. The only reason it exists is to differentiate the postfix from the prefix. And that's it. So let's test that. I'm going to go ahead and just show everyone that I'm not just lying here. The first one was a prefix, and the second one was the postfix, as you can see right there. So keep that in mind. If you want to overload the increment or decrement operators, include an implementation for both the increment and decrement operations. Okay, so now that we have our prefix and postfix, I'm going to leave the prefix operator implemented, because that's really what it should be implemented as. But can anybody give me an implementation of the postfix operator in terms of the prefix operator? In fact, I'm going to go ahead and leave that as a... so don't post your answers in BuzzNet until I get back. I'm going to go ahead and put this up on the screen. So implement postfix operator in terms of prefix operator. And postfix operator is line 39, and the prefix operator is line 32. And I'll leave the code up on the screen as well as this prompt. And it's a dead simple implementation, but it might be a little bit confusing to come up with at first. Is that how pointer versus multiplication work? The end parameter, that is? No, I don't really know what that means. I'm not understanding the question. The end parameter is just a dummy end parameter. That's it. In fact, I'm curious. Hold on. I'm going to give this a name. I'm going to print it out. Never actually done this bit before. Seems like an obvious thing I would do, though. Let's see what blah is. Actually, hold on. Let me delete all of that. Blah is 0. So, the C++ compiler actually passes in 0 into the increment operator. Fun stuff. All right, let me find my notepad window. And I'm going to go ahead and hit pause. Is it 0 only in debug, though? I don't know. Give me a sec. How do you set it to release? Okay, if anybody tells me how to assign or how to set up... Oh, there we go. Found it. Ooh, yeah. It is actually on the toolbar. Funny story, I always disable the default toolbars. And honestly, the fact is that I'm used to the professional version, which has a nice configuration option menu up here. I only use Express for these classes. All right, let's see what the output to this program is. Wait, what? Oh, derp. See, I'm just curious right now. I want to know what this is. Yep, it's just 0. That's all it is. Okay, so prompt time and outside time. So I'm going to go ahead and, yeah. And we're back. So to implement the postfix operator in terms of the prefix operator, a lot of people did something like this. Vector2, let's say results, use the copy constructor just like we did before. And then increment our own stuff. And then return the result. Which the result is going to be, and this does have the behavior of the postfix operator. See, we make a copy of the existing things, we mutate the current object, and then we return the copy. Keep in mind, though, that I actually did make a slight mistake here. We really shouldn't be using a reference here. And actually, everybody who posted also got that, which is good. But we shouldn't be using a reference here because we're returning a copy. Instead of saying that I forgot something, I'm just going to say it was a test. So this is close, but we can do a little bit better. And the way that we do a little bit better is actually an interesting aspect of operator overloading itself. And that is, operators are literally methods. And we can actually access them as if they were methods. Meaning, we do not need to duplicate our functionality on line 43 and 44, which is the same functionality we have on line 35 and 36. So what we can do here is that line 43 will actually invoke the method defined on line 32. Tizer, if you do this, what's going to happen is you're still going to mutate this before it returns. So it'll still increment at first. Okay. Oh, you mean you did this. That will work too. While that will work, I would personally prefer to see the operator ++. I think that provides a little bit more readability. But it will work if you do it like this. That'll do the same thing. Yeah, I'm really bad with pronunciation, if nobody has gathered that by now, especially names. Now keep in mind that those two options that we just went through on line 43, they do the same thing. They compile into the exact same code. Okay. So now talking about other things that we can do. There are a few other operators that we can go ahead and overload. I'm not going to go over all of them, but I do want to point them out. We can overload the pointer operator. So let's say we have a vector2 pointer operator. This is bad. I don't even know why you would ever want to do this. But you can. I do want to point out that this operator, in fact, is useful when doing iterators. In fact, we've used an overload to this operator before. So for example, I'm going to bring up a vector. And then I'm going to create a vector of ints, and I'm going to iterate over them. No, I'm not. I'm not going to create a vector of ints. I'm going to create a vector of vector2 pointers. Oh, this is going to get confusing. And so I can do now for auto I equals vect begin, I does not equal vect end, I plus plus. Notice some interesting things here. Iterators overload the inequality operator, the postfix and prefix increment operators, as well as the pointer and direction operator. Meaning what's interesting is, so you'll notice that if I go down to operator, actually, am I mistaken on this one? I was thinking about auto pointers. Derp. Ignore me. I was actually thinking about something we haven't gone over before, which are auto pointers. So if I have an auto pointer to a vector, something like this, or a vector 2, sorry, I can do vect pointer. And we haven't talked about auto pointers. I really don't want to talk about them, but I just wanted to show a useful example of overloading the pointer resolution operator, or the pointer dereferencing operator, or the pointer member dereferencing operator. I always forget the name of it. So yeah, fun stuff. A few other operators that we can overload that are useful is, in the case of one more, and we did have a question about this. I'm going to have a vector of ints now. I'm going to say int pushback 10, 20, 30, and then so this is cleaner, Nelson. That's a good point. That's a good point. In that particular case, I would prefer to use this syntax right here instead of the suggested syntax which somebody brought up, when I could have simply done operator plus equals RHS. Actually, no, I couldn't have done that. I would have to have done something else. The point is that, yeah, it's going to be subjective to wherever you are thinking about your stuff. So I guess that wasn't a hard, fast rule. It was more or less my own sort of, my own sort of conventions and what I consider to be cleaner code. So, yeah. But anyway, getting back to this, can anybody remember how I would access the current integer that the I iterator is pointing at? Because this is another example of a useful operator to overload in certain circumstances. Right. I would do cout dereference I. And that actually makes sense. I'm using the dereferencing operator to dereference from an iterator to a value, which follows the implicit sort of convention set forth by the operator itself. Now, how would we overload this operator compared to the binary multiplication operator? Well, let's take a look at that. So I'm gonna write a vector 2 operator multiplication const vector 2 right hand side const, and I'm just going to return this so the code compiles. I'm not worried about implementing this right now because, again, it's a nonsensical operator to begin with when in regards to vectors. This is the binary multiplication operator. However, this is the unary pointer dereferencing operator. The difference between the binary and the unary is going to be how many parameters it takes in. Keep in mind that so far we've only been declaring operators within the class itself. We have not been declaring operators outside of the class. Whenever you declare an operator overload inside of a class, the left-hand side is implicit and is essentially going to be this. So all you have to do is count how many parameters are being passed in. This one is a binary operator because we have our implicit left-hand side, and then we have our explicit right-hand side. This is a unary operator because we have our implicit left-hand side, but we do not have an explicit right-hand side. So, fun stuff. See quite a few people leaving, actually. I've lost like 5 people over the last 30 minutes. Woo. But this is interesting stuff, and I want people to keep in mind that operator overloading is very, very useful in certain circumstances when used correctly. I do want to point out another interesting aspect of operator overloading. But before I do, is everybody good on the this syntax and this syntax? All right, it's not that terribly complicated. You won't be overloading these operators very often, but you will be using operator overloads of these types very often. So if you notice that you're using it, be cognizant of the fact, because these two operators, the pointer member dereferencing operator as well as the dereferencing operator, they both have different meanings if used on primitives or pointer types than if used on an object that overloads them. So I'm going to create a vector 2 with 1 and 2. Notice something interesting. If I do vect dot, IntelliSense, why is my operator returning a pointer? Because it's going to typically return a pointer. That's really just it. It's going to be typical because notice, and this is a funny aspect of this operator, if this operator returns a pointer, in this case, it's actually going to double in both what I overloaded and what it actually means. So it actually has both meanings right now. Not only am I returning a point, or not only am I invoking this operator defined on line 58, but I'm also doing a member dereference of the pointer returned on line 58. If instead let's say I had something, let's say I had something like this, which is really weird. This isn't going to work right. Now, it's certainly going to compile, but I can't do this. This syntax is only ever going to be useful if this operator returns a pointer. That's it. So I'm going to go back to returning a pointer, and keep in mind, when I return a pointer, again, this doubles as both invoking my operator and what it usually means. So for example, if I did vect dot operator this, that's the same thing as doing this. Notice that on line 69, the operator is used twice. Once to invoke it on the vector, and then once to dereference the pointer that was returned by the operator. But we can do a shorthand right there. Certainly, you can return a pointer of any type you wish. So for example, I could return a pointer of a vector of ints if I wanted to. And obviously it's no longer going to compile, so I'm just going to return a new vector of int for it to compile. Now if I do the syntax, notice how my code completion list is now a vector. That's how auto pointers work. So when we get to auto pointers, remember this discussion, because auto pointers do overload that operator. Same with the other pointer wrapper classes. Okay, so that's really about it for the pointer types. I do want to point out, though, that there are a lot of weird things that you can overload that I'm not even going to actually be talking about or showing examples of, but I want to just point them out if I can remember the particular ones that I'm intending to demonstrate. I think that I'm completely... let's think here. There was one weird one that I wanted to point out because it's similar to what I just showed. Right. So you can actually overload the that operator. I have no idea what that operator even does, but you can do it. You can overload it. Don't know what it does, but you can do it. Okay, so what other operators can you overload that I'm not going to talk about? We've already talked about a lot of the binary stuff. It won't come as a surprise to everybody that you can also overload the modulus operator. You can overload the modulus equals operator. If I can find it on my keyboard. You could overload the bit manipulation operators, so that includes and ors and XORs, or nots and XORs, and all the other bit shifts operators, and all their corresponding assignments. You can overload equality, inequality, greater than, less than or equal to, greater than or equal to, logical or logical ors and logical ands. You can do all that. Keep in mind, though, that the rules that we've been talking about before are still important. So, for example, if you overload the equality operator, you really should overload the inequality operator. However, that being said, this or the less than operator is actually useful to overload on its own sometimes. And the reason is, can anybody guess why the less than operator is useful to overload on occasion? It's actually kind of important when using the STL. Right. So overloading the less than operator will make your type sortable. So in a way, it's sort of conceptually similar to C#'s get hashcode method that's available on Object. So it's used for sorting and buckets, and well, it's not used for buckets, but it's used for sorting and stuff like that. And other fun stuff. What else can we do? We can overload the new operator, the new array operator, the delete operator, the delete array operator. Those are fun operators to overload. So, for example, I can say, now it's important to keep in mind what these methods should return. An overload of the new operator should really return a void pointer, which we haven't talked about. And I see that Atomizer already knows what that is, but still, I'm sure quite a few of you guys know what this is. But we haven't talked about the void pointer yet. That thing is awful. Well, then again, it's not any worse than passing around objects in C#. So then we can overload the new operator, and then we get a size t size, and that's it. So you can do a lot of fun stuff with some sort of operator overloading, but I'm not going to really go into that too much. So is everybody good with these so far? Because there's two more operators that we're going to be doing today, or talking about. Because these operators are actually very useful. K7, not those. Those should be implicit. And well, I'll go ahead and overload those operators for you just to show. Overloading the equality operator, I'm going to take in, const vector to RHS const return x equals RHS x and y equals RHS y. There's not much to say about this. Okay, the last two operators that are going to be very useful to overload are the indexing operator and the N-ary operator. The indexing operator should be fairly self-evident. So let's go ahead and talk about what fun stuff we can do with that. Let's say I had an inventory. And the inventory had a operator for, let's say, a string operator index that took in a const, how about just an int ID? And it just returned, hey there, or something. And it returned a const string, of course. And it's const. This syntax is actually useful in certain situations. So if I go ahead and say inventory, inventory, I can now say cout inventory. Let's say I want the product with an ID of 2. And I am getting a warning right there because I'm returning a const string pointer when I should really be returning a string. Derp. But anyway, so if I run this code, you'll see that we get hey there. Did people see the usefulness of this operator? Another interesting thing of this is that unlike C# with indexers, you may not have multiple parameters passed into this. I forgot, can you take in a string for this? Yes, you could take in a string. I could say const string hey, and let's say it just returns hey plus there. So now I could pass in whoa. And I get whoa there. So, useful function is used by many of the containers in the STL and is useful for your own stuff. Again, the limitation that you cannot pass multiple parameters into this method is kind of annoying, but there you go. All right, let's talk about the N-ary operator. How do I invoke? Okay, I have 2 questions. First question is, how do I invoke the N-ary operator? The N-ary operator I defined on line 62. Atomizer, yes, that is what map does. Map uses the indexing operator. Yes, you invoke the N-ary operator with parentheses, just like a function invocation. So notice how I've essentially turned an object into a function. This actually has a term. Does anybody know what the term for an object used like a function is? Now, it's not a delegate. It's a functor. You have defined a functor. What's interesting about functors is that they're very, very commonly used as a sort of replacement or a sort of, I guess you could say, kind of a kludge in C++ to behave similarly to delegates. You can think about the N-ary operator or a functor like a thing that takes in, or an interface that has one method on it. And it doesn't matter what interface it is. See, that's a very important aspect for things like sorting algorithms. Before doing this, there was no way to pass in, well, there are things called function pointers in C++, but function pointers are very difficult to work with. And function pointers do not include member function pointers, which are bits of different syntax. So we can overload the N-ary operator and get something that behaves similarly to an actual function and use it inside of templates or templated functions. Function pointers are mostly left over from C. Yes, function pointers were in C, heavily used in C. They're heavily used in C to replace or to provide polymorphism, which is in C++ obviously exposed through inheritance. You still will use function pointers in C++ from time to time. Generally, when doing interop with C code, like in Win32, sometimes you'll do it for other purposes. But typically, when you have a method, like let's say I wanted to make a generic method called void list all files, and then I could take in a something here, and then I could say strategy, or I don't know, outputter. And then I can say for each file in file system, invoke outputter. Something like this. Now what I can do is, we're not going to be talking about templates, but I do want to point out why functors are important, and why occasionally, why it's kind of interesting to know about them. By making this a templated function, I can now pass in any object that overrides the N-ary operator that has one parameter that is compatible with this file local variable. And just for a fun little tidbit for people who are, already know most of the stuff I've been saying, which seems to be the majority of the people in the class, this is also how you use lambdas in C++ 11 with this sort of syntax, because lambdas are compatible with functors. So whenever you have a function in the STL that requires something special, like let's say there's a sort function in the STL that allows you to pass in a different behavior for sorting, you use a functor. And like, for example, there's also things like the for each method, which I don't have imported at the moment because I can't remember which header it comes from. But there is a for each method that allows you to pass in an iterator, a begin and end iterator, and you can also pass in a functor or a lambda into it. Okay, so is everybody kind of good with what functors are? Functors are just objects that you can invoke with similar syntax to methods. They're very useful for writing polymorphic functions. Okay, can anybody tell me why this is called the N-ary operator? Yep, N-ary. Yep, this is the N-ary operator because we can take in as many parameters as we want. It's also called the function call operator. You'll probably hear people call it the function call operator more than the N-ary operator, but it is an operator. It is an or a prefix N-ary operator, and that's really all it is. So those are the two interesting operators I kind of saved for last because they have a lot of interesting meaning to it. Just for some fun, let's do something fun. Yes, you may overload the comma operator. So, does everybody see what's going on there on line 73 and line 62? I do want to point out something good about C++. The author of C++ wanted to introduce the whitespace operator, but he never got around to it. Or he realized it was a bad idea, either or. So does the N-ary operator use operator in params? I don't understand the question. We did get a few actually questions that I've sort of been neglecting up until now. What's the difference between the bitwise AND operator and the logical AND operator? Is it just a short-circuiting used with logical AND? Yeah, the difference between this and this is that this is a short-circuiting logical operator, whereas this is a bitwise AND operator. They both carry different semantic weight. This performs a bitwise operation on two integral values, or whatever you want if you overload it, of course. You know, this operator you could set up to send an email to your boss, or restart a mainframe if you wanted to. And then this, of course, is the logical AND operator that we've been using pretty frequently throughout the class. Can we overload any character operator? No. I've pretty much gone through every operator that can be overloaded. I'm probably missing a few, but that's about it, really. Ooh, somebody asked a good question, actually. Let's say I had a function called ble that took an enconst inventory reference. Fortunately, this is a compiler error, but I'm sure if I wrap these in parentheses, it will no longer be a compiler error. So, yeah, if you wanted to use the comma operator in the context of a method, you're going to have to wrap it in parentheses. That's because the order of operations for the comma operator is very low in comparison to parameters. So you're going to have to wrap in parentheses. Notice how if I don't wrap in parentheses, it thinks that we're trying to pass in two inventories into ble. Okay, well, that was Roland's question, so I'll give him credit for that. Reference versus binary AND. Would it be just no parameters for reference, like the pointer? Well, the binary AND, if you implement it in terms of our class, something like vector2 operator binary AND const vector2 reference RHS const, you'd only take in one param. And the same thing goes for doing the logical AND operator. Both of these, and of course the logical AND operator, I would want to return a Boolean. Both of these are how you would represent them and stuff. All right, any more questions about awesome operator overloading? I hope that I showed some people some fun stuff. At the very least, stuff that people can take advantage of in math-oriented classes, and as well as some interesting stuff, and as well as hopefully clearing up people's understanding of how existing bits of code work. So like iterators will overload the dereferencing operator, auto pointers will overload the pointer member operator, and so on. And then I hope you guys learned something new about functors, because those are fun stuff. And yeah, that's about it. The last bit that I want to go over is something that's very interesting. And that is, in C++, you do not need to define an operator for something inside of the class. So, for example, if I wanted to do something like this, and this is a great debugging tool. I personally like this a lot. So if I said vector2, vector2, and 2 and 2, or something like that, let's say I wanted to print out this. So vector2, vector2. Notice how the left shift operator is being used in cout, but we haven't actually, there's no overload of vector2. We defined vector2 right here. There's no way that the people responsible for standardizing the C++ library would know that I would one day have a vector2 class that behaved like this. So we need to actually add an operator to the cout, or more specifically to the Ostream type that understands vector2. We do that by providing an operator outside of any other class definition. So now I can say Ostream reference operator left shift Ostream in const vector2 reference RHS. And then I can say, or this shouldn't be in, this should be out really. Now we can say out RHS get X, RHS get Y, and maybe to make this look a little bit nicer I can wrap these in parentheses. By doing this, we get a compiler error. The reason we get a compiler error is I forgot to actually return out of this operator. Now this is important. I could have quite easily made this operator not return anything, but that would make it impossible for me to chain multiple invocations of this operator. As you see, that's a pretty important aspect of working with the standard out stream in C++. So now that I've defined an operator outside of anything else, notice how I can now print it directly to cout. In fact, I can print it to any type that implements the Ostream class, or inherits from the Ostream class. Not only that, we can also provide operators outside of vector2. So for example, let's say I didn't want my multiplication operator to be inside of vector2, I want it to be outside. I can now say vector2 operator multiplication const vector2 LHS const vector to RHS, and then I could say, I don't know, return vector2 1 1. Okay, and I can of course invoke it if I wanted to. So vector2 1 1 2 vector2 2 vector2, or just cout 1 times 2. What should line 51 be if I consider multiplication of vector2 being the multiplication of both the x and the y components? What should line 51 be? Can anybody tell me? Write out a sensical implementation of this operator. And that's exactly what I was looking for, K7. The reason I was looking for it is that it's wrong. Can anyone tell me why this doesn't compile? Yep. Because this method is defined outside of vector2, we do not have access to its private members. So the implementation that would work, and again, I was legitimately looking for people to do that because it would be, an obvious thing to do, but it's important to keep this in mind when doing operator overloading outside of the class. We only can access the public members. Is my audio cutting for anybody else? Or is everything good? All right, I'm a bit worried because earlier today there were two Comcast trucks out at my neighbor's house. So, all right, but did everybody hear what I was saying? It's when implementing an operator outside of the context of the class itself, we can only access its public members. Sure, unless it's a friend, but I'm not getting into friends today. I mean, we did talk about friends earlier, but not friend methods. Okay. So, are there any more questions about operator overloading? Because there's really nothing else. I mean, there is one more fun thing that I want to do that I actually, I mean, negation. Keep in mind that you can overload like for example, I could do something like vector to operator negate const, and then I don't know, return this. And then I can also do, or what's interesting is if you try to do something like this, you can also do that. So these are overloading the Unary, negation, and thingy operator. Frankly, I do not know what the Unary plus operator is. In fact, on basic data types, it is actually a no-op. Like, quite literally, it is a no-op. It does nothing. Would negation operator be good for flipping the vector component signs? I wouldn't have a problem seeing that, personally. So the question was, is this a valid thing? So for example, if I returned a vector 2 with minus x, minus y, I really wouldn't have a problem with that. However, being that I mean, negating a vector, to my mind, there's only one way to do it, but I could be wrong if there's multiple ways to interpret that. So I wouldn't see a problem with it on top of my head. Okay, so I guess everybody's good with operator overloading. I'm going to keep this up if anybody has any more questions. This is just a fun aspect of C++ that I was just reminded of as I was going through researching for today's class, because I wanted to make sure I had everything down. But I did find something, or I did remember about something interesting that I knew a while ago but completely forgot because it's inane. Actually, no, I'm not going to do that. Actually, I'm confusing myself here a little bit. I really wanted to show off something strange, but now I've completely forgotten what I was doing. Yay! So while I actually remember, I think I'm going to go on break and wait for people to fill in questions. All right. As far as homework for last week's class, I believe that was just wrapping up something that, or at least the code that we were previously working on. Because we did do some interesting things with the code. Yeah, doing the const stuff correctly, I think. Okay, so an interesting aspect of one more thing that I do want to just point out really quickly. Actually not, oh, derp. Okay, so what's the output of this program? Now, people might be going, well, it should be whoa, do stuff. But think about that really closely. It works. Okay, so I'm going to go on break, and then I'm going to ask people for the reason why this shouldn't work. So I'll be resume, and we're back. So again, this is just an esoteric thing. I kind of wanted to leave people on break with something interesting to think about. This is a feature of C++ called ADL, or Argument Dependent Name Lookup. And what it means is, essentially, that if a parameter of a type within a namespace, if there's a function inside of a namespace that takes in a parameter of a type within that same namespace, then that method will actually resolve without importing the namespace. So the reason I expected people to be confused, and I did expect people to be confused, is that we're not doing an import of whoa. Whoa is not being imported, nor are we prefixing do stuff with whoa, or whoa with do stuff. No, the other way around. So what we have here is an example of ADL. Fun little tidbit of C++ isms. We'll be looking more at ADL later once we start talking about templates, because they do play an important role with template metaprogramming. In that, we can actually provide, with template metaprogramming, we can provide the canonical, wow, I'm not even going to try to pronounce that word. The most commonly used example of ADL being a good thing is swapping. You'll see that example everywhere, but it applies to every sort of operation thing, where the authors of the STL wrote a bunch of methods that did different things, but they wanted to provide the opportunity for you to override which methods get invoked depending on the actual type that's being passed in. So it's an interesting advanced feature. Again, I just threw it in as a little brain teaser for everybody here to have some fun with, just because I came across this and I was like, wow, I forgot about that. That's another weird thing that C++ does. So I hope you had a lot of fun thinking about that. We'll get into more ADL stuff once we start talking about templates, because that's when it becomes actually useful. But it's also useful in this case, I suppose you could say, because importing namespaces is actually kind of frowned upon. Now, you should never import a namespace in a header file. I'm starting to sound auto-tuned. You mean the pitch of my actual voice, or some sort of anomaly in the wires that transport my voice from Washington to the rest of the world? Okay, so again, I'm having finicky internet issues, so yeah, fun stuff. You can use it with, like I said, importing namespaces is typically frowned upon. You should never import a namespace in a header, of course. But even in CPP files, the amount of namespaces that you import is something you should keep track of. And by doing this, we can import fewer namespaces, because now I'm able to invoke any method inside of the whoa namespace that takes in a test without actually importing the namespace whoa. What about using std string directly? I'm kind of confused what you mean by that. Oh, sure. Using specific things is fine. So using std string is fine. In fact, I will typically just import all of std because I'm lazy like that. But when it comes to other libraries, and you really shouldn't do that, what you should really do is say using std cout, using std string, using std cin, and that will leave your global namespace nice and untouched. Because now if I hit Control Space, we do have a lot of clutter anyway from everything that was brought in by the global namespace, but we have a lot less clutter. Ooh, in a header, I would not use std string or do it using std string unless it's encapsulated within a block of code. But okay, so that about wraps up the stuff today. Are there examples in the standard libraries where a function takes in class same namespace as to no use and blah blah blah? Yes, there are. I can't think of any on the top of my head, but it is used in the standard namespace a lot. I mean, yeah. There are also other interesting things. I'm actually kind of cheating here. I did bring up the wiki article as I remembered. Oh, wait a sec, I can show you these guys some fun stuff. And there's an article on wiki that you can go look at. An interesting other example is this. Think about this. Think about this very carefully. The Ostream left shift operator doesn't actually exist in the Ostream class. It's just a floating function. Because of ADL, or argument dependent lookup, what we can do is we can access the operator, which looks like this, std Ostream reference std operator left bit shift std Ostream reference RHS const character input. This operator exists in the std namespace. It's just a floating function in the std namespace, but we can use it right here on line 9 because of ADL. If this wasn't the case, we would have to import the entirety of std. But because of ADL, because it knows that we are accessing an Ostream, and it knows where Ostream is defined, it properly looks up the name correctly. But again, slightly esoteric, a little bit of fun syntax I wanted to throw at everyone, just because, you know what, I love languages, and I love weird quirks in languages. And as much as I complain about C++, the amount of weird stuff you can do in C++ is actually slightly intriguing to me. So I did get a question, can you do end-L? Now, the end-L is an interesting thing. End-L is actually a function. Pointer. If you go to the definition of end-L, oh great, I am not going to digest these defines. So I'm not even going to worry about that. The point is that end-L is a function pointer. It's not an actual function invocation. Yeah. Yeah. This code really isn't that easy to read. And one of the reasons why it isn't easy to read is because of all of these defines everywhere, defines, and this bizarre indentation formatting that they decide to use. But the point is that hopefully this code is actually less scary now than it would be if you guys do it. Do I understand any of this? Well, I understand this bit right here, inline basic Ostream taking in a character, passing in the character traits and its reference to it. If I jumped into CRT IMP pure, which is defined as this, which is actually empty. Okay, so this define actually doesn't do anything. So then if I jump into CLR call or cdecl, the difference between these are the calling conventions of the function. We're not getting into calling conventions, but that's the calling convention of the method. There's the method name, and there's its first parameter, which is just a basic Ostream of character and character trace of character reference. So yeah, you can go through, you can parse this. It's actually fairly straightforward. We have a inline function that returns a basic Ostream reference that has the cdecl calling convention. Its name is endl. It takes in a basic Ostream reference. It invokes the put method on the Ostream reference, and then invokes the flush method on the Ostream reference, and then it returns a reference back to the Ostream. I mean, there's not much more to say. That's what it does. And that's just reading through the code. It's not easy to scan this code because of the indentation style I absolutely abhor, but if you go through it character by character, you can typically read it. Yeah, and this is an interesting point. This is why people commonly say, "Ooh, you should use endl because that supports Unix and Windows line endings." The answer is no. A new line character in the standard library gets properly translated depending on what operating system you're on. So no, that's not the answer. The reason is endl flushes the stream immediately after adding the new line. That is the difference between using a new line character or escape sequence and using endl. Now, on the console, it's not as important, but when you start talking about files, it starts to become a little bit important. That being said, it can lead to performance degradation if you are not intending for your stream to be flushed. Okay, so that's really about it. So for homework today, we're going to have to push back writing code until next week, and we'll actually start the lesson off with writing code next week because, yeah, operator overloading actually took longer than I had expected it to. But we had a lot of interesting things to talk about. Oh, somebody did ask, is there any performance difference between using this and using this? Can anybody guess which line is faster? Ooh, he means character or string. Well, even in that case... okay, so is there any difference between this and this? My gut tells me that this is nano of nano of nano of nanoseconds faster. The only reason I'm saying that is because, well, two reasons. Atomizer actually pointed out another great reason. So I'm saying it for two reasons. First of all, both of these pass in the same amount of data. This passes in a character, which is 1 byte in C++. This passes in a character pointer, which, well, actually, to be fair, that's actually 4 bytes. But it'll still amount to the same thing on a 32-bit operating system, so it doesn't really matter. However, to actually access the data within this, it has to dereference the pointer, whereas to access the data within this, it doesn't have to do anything. And the second aspect of this is that remember that all C strings are ended with a null terminator. So the code that actually runs line 10 actually has to go and parse until the null terminator. That being said, that is what that is what programmers refer to as a micro optimization. And as far as if these two are faster, I would say it's line 11 that's faster. But what about this versus this? Now we start to get a little bit more tricky, because now while we can argue that line 12 is probably faster, I can also argue that line 10 is going to involve a method, a function invocation. So could potentially, because that has to allocate a stack frame and all that stuff. But again, we are talking about individual CPU cycles at this point. But keep in mind that micro-optimization is not something that people should necessarily be concerned about, except for in two cases. One, academic, and two, when you actually notice a problem. If you notice a problem in your code, a performance problem, I absolutely guarantee you, and if I'm not correct in saying this, then I'll give you $200 right now. If I'm not correct in saying this, if you notice a problem in performance of your code, of your program, I guarantee you, and this is for $200, that the difference between invoking cout with a character and a string is not your biggest problem. It's not that they may or may not be faster, it's that they're not your biggest problem. You can always optimize bigger bits of your code than the tiny micro-optimizations. That's why they're called micro-optimizations. They're not macro-optimizations. A macro-optimization would be fixing a select n+1. And if you don't know what that means, that's when you select records from a database, instead of selecting all of them at once, you individually select every row, which results in multiple database calls. Those are the kind of macro-optimizations that will make or break a program's performance. These sorts of micro-optimizations don't even register as a blip. But then again, I don't mean to discourage anybody asking questions about this. I just wanted to throw that caveat in there, because from an academic standpoint, they are fairly interesting to think about and to reason about. Oh yeah, especially won't be important in a console ASCII game. Yeah, in a console ASCII game, the slowest thing that you're going to be doing is literally I/O to the console. And I'm not talking about the difference between this and this. I'm talking about the amount of time it takes to actually write characters to the character buffer of the console. So the question was, if you use the same string over and over again, do they point to the same bit in the function pointer table? Well, I'm 99% certain that they do. They should. Really, they should. If they don't, I'm slap Microsoft. But we can prove it. Let's go on an adventure. So the question is, do these similar strings point to the same address in the string table? And I don't guarantee you, but I'm pretty sure they do. And as we have proven, they indeed do. Of course, that is a compiler-dependent feature. That is an implementation detail of the compiler. It's not guaranteed to be true. But it's a very sensical optimization. Yeah, something makes sense in CPP. All right, homework. I kind of feel mean for doing this, but let's have some fun. You guys ready for some fun? Are you guys up for the challenge? Because with the lack of code that we actually didn't write today, I felt like I had to make it up with something equally as interesting. I want people to write a Big Int class. A Big Int class can represent an int of any numeric value, unlike 32 or unlike fixed width ints, for example, primitive int type, must support the following operators: addition, subtraction, subtraction, blah, blah, multiplication, multiplication equals. I'm not going to do division. I'm just going to do these. Must also support equality, inequality, greater than, equal to, or all that stuff, and so on. So all those binary operators must support the Unary negation operator, and it also must support the Ostream operator as well as the iStream operator. Well, if you guys think of any other what other operators do you want me to have you guys write? I mean, it's also going to need a copy constructor, a destructor, and assignment operator. ToString I feel is handled by the Ostream operator like this, but if you guys want to, sure. ToString method returns const string reference. Yes, and again, you must implement the copy constructor, destructor, and assignment operators, because you will be forced to allocate dynamic memory. So if there's any other suggestions, is Ostream the one that lets you use SSStream? SSStream is an Ostream, if I'm not mistaken. I'll prove it, but just because I don't like being wrong. I hate being wrong. StringStream does indeed implement or does indeed inherit from Ostream, so therefore I'm not going to worry about a ToString method. That can be handled. Doesn't C equals equals have an overloadable conversion operator? Yes, there are conversions in C++, but we didn't get them to them today, so I'm not going to worry about that. Don't worry about modulus. I'm not trying to freak everybody out. Keep in mind that probably the only people left in class right now are, the hardcore people, and I don't want to freak out the people watching the video too much. Should most of these be non-member functions? That's up to you. Personally, I would make them member functions, because I consider them to be an actual very important aspect to this particular class. What's the trick to make it vary in size? Dynamic memory allocation. Is the number actually going to be a string or something? That's up to you. Of course, that does do dynamic memory allocation behind the scenes, but that's totally up to you. Yeah, I wouldn't recommend it either. Still confused about how that works. Well, think about it like this. Think about implementing. Didn't I have you guys implement a dynamically sized array in 101? Thought I did, but the idea is that you can detect if you are going to run out of memory, and then you can allocate more memory if you need it. Anyway, I hope this is a fun little assignment. This sort of stuff is, I personally have a lot of fun doing this sort of stuff with C++. Because it feels like that's an appropriate problem to solve in C++. All right, so are there any more questions? How do you detect when you run out of memory? It depends on the storage mechanism. If you're using an array of ints, then you can find if you're about to run out of memory by doing something like, size of array of ints multiplied by the max value of int. And the max value of int will be something like int or std traits, or what are they, numeric limits. Yeah, numeric limits, int max. So if you take the size of your array of ints and multiply it by the max value of int, then there's a way to identify if you're about to run out of memory. Or include C-limits. I wouldn't include C-limits. I would use the std numeric limits specialized template instead of using the C-limits header. Yeah, and then ctor is a constructor, dtor is the destructor, and I'll spell that out when I make the post. But that's a very common moniker in all languages that support either dtors or ctors. Yeah, it's a fun little math problem. It's a math problem and a C++ problem at the same time. And you get the opportunity to actually overload a lot of fun operators. And I hope you guys aren't being sarcastic, because I'm not. And this is seriously cool stuff. But then again, I'm weird. So, alrighty. So, that's really about it. So, I'm probably going to go ahead and... I read a book and a guy mentioned someone can make his own 32-bit pointers before they actually were available. Is this how? Quite possibly. Or he could have simply made a type that contained two, or just an int. I mean, I'm not really sure, because if you can make a 32-bit pointer before they're available, that means that your system that you're running on doesn't support 32 bits worth of addressable space. So I'm kind of confused, actually. Yeah. Okay, so I think that about wraps it up. Clocking in at 1 hour and 58 minutes. So to all the future people, goodbye, and I'll see you guys later.